Let's take a brief moment and notice that how Kiara really stands out when it comes to all other databases available in the market. The first very distinguishable feature of Kiara DB is that it says you can search by anything without building indexes, which means in your search criteria, you can specify any combination of your conditions um, and get the results back in high performance without having to worry about any building any composite indexes. Now this is huge. If you have worked with SQL queries a lot, you would know that whenever you build a SQL query for your application, you notify your DBA that you're using these condition in your where clauses, these data attributes or columns in your where clauses, so that your DBA can build an index out of those data columns, so that when you execute your query, you get better performance. This is not the case with Kiara. You can search by any combination of data attributes that you have, and you'll get high performance, and you don't have to worry about building indexes. Another thing to notice is that when you're dealing with other databases like SQLite or Redis or Oracle, um, you will not have the freedom to search by any possible combination of columns. If you want that feature to be there in your database, that a user can search by any combination of columns in good performance, in consistent good performance, then you need to create these many indexes. Let's have a comparison. If like Redis is based on hash indexes, or any a key value pair index database uses hash indexes. If you have 5 attributes, you need 32 indexes to support all possible combinations of data searches in high performance. If you have 10, the number of indexes you need with hash indexes is 1,000. If you have 100 columns, 100 data attributes in your data set, the number is very huge. It is not achievable at all. When it comes to B-tree, B-tree is much better than hash indexes, but still it is not possible, even with B-tree indexes, which is used by SQL and most other databases like SQLite, Oracle. Um, so with B-trees, if you have, say, about 10 columns, you need 46, but if it goes to 100, you need 5,000, and the number starts growing after that. So it becomes a problem beyond, say, 10, that you cannot build so many indexes in memory when your number of data attributes increases. But this is not the case with Kiara. You don't have to build any composite index with Kiara. Kiara only deals with single indexes, that is, index based on only one column, and you don't have to worry about any combinations. And Kiara will return results in consistent high performance with these single indexes. So this is one of the very distinguishable feature which really stands out. You can search by any possible combination without having to worry about that. And there's other cool features of memory optimization. If you click here, it will talk more about the implicit memory optimization compression techniques and the explicit techniques that you can apply. Kiara has a very rich interface for flexible searching. You can search on simple types like numeric, alphanumeric, or datetime types, or range types, or list of array types. It has a very rich SDK library to get you the data that you want in a very flexible searching techniques. But this is you can dig in more later, not for the demo project. It is very developer friendly. Kiara has the very tiny boilerplate code. Loading is as simple as just loading your, just passing your plain old Java object to a function Kiara SDK provides, and it loads your databases. And searching is also a very simple operation. You just specify your query, and it will return you results. So it is very developer friendly. It is scalable, NoSQL architecture. So scalability also is not a concern. With Kiara, it can be easily scalable by adding more machines. This was a brief introduction about how Kiara really stands out.